Talking Steel at Sterling Steel. Sterling Steel uses 100% recycled scrap to manufacture steel. The scrap is transported to the furnace to be melted. Up to 4 buckets of scrap are required to make 1 heat of melted steel. With the electrodes removed, the roof of the furnace is raised. The entire superstructure is swung to the side, leaving access to the top of the furnace. The scrap bucket is then positioned over the top of the furnace. A clamshell mechanism is opened on the bottom of the scrap bucket, which allows scrap to fall into the furnace. Once the scrap is in the furnace, the clamshell is closed and the furnace roof is swung back into position. The electrodes are lowered until they form an arc. This electrical arc generates the heat used to melt the scrap. This is repeated until the needed amount of steel has been added. It takes approximately 2 hours to completely melt the heat of steel. Each heat is roughly 360 tons. During the melting operation, an oxygen lance is used to supplement the heating process. Once the heat of steel has been completely melted and the bath has achieved an optimum temperature, it's poured from the furnace into a ladle. The ladle is then transported to the secondary refining furnace, where all of the elements will be optimized to be within specifications. Impurities are removed from the steel by means of bubbling argon gas through the ladle. This bubbling action also works to make the temperature of the metal consistent from top to bottom. Once the refining process is complete, the ladle is moved to the continuous caster. At the caster, steel is poured from the ladle into a trough called a tundish and allows a reservoir to form. This enables the uninterrupted pouring of several heats of the same grade of steel. Steel flows from the bottom of the tundish from 8 separate streams into a water-cooled mold, which is 5 1/8 inch square. This mold is used to solidify the skin. As more steel is poured into the mold, a continuous length of solidifying steel is pulled from the underside of the mold. As the section exits the mold, it's cooled with sprayed water until it is completely solidified. At the base of the caster, the solidified section is cut with a torch. Each piece is called a billet. A billet is 5 1/8 inch square, approximately 35 feet long, and weighs about 3,000 pounds. Each billet will make 1 rod coil. The billets are allowed to cool prior to storage. The billets are then transferred to the rod mill where they are placed in inventory. Individual heats are stored separately within each stack. A rod mill consists of 25 sets of rolls, which reduce the billets to their final round shape. Sections as small as 7/32 can be obtained on this mill. Prior to rod rolling, the billets are heated to a uniform temperature, approximately 2,000 degrees Fahrenheit. The heated billet exits the furnace and proceeds through the individual mill stands. As the section is reduced, the speed of the material increases. 7/32 inch rod will achieve speeds in excess of 200 miles per hour at the end of the rod mill. Following reduction to final size, the rod is processed through a laying head. The laying head imparts a circular shape to the rod and allows it to cascade onto a moving roller conveyor. The roller conveyor allows for the controlled cooling of the steel rod. The laying temperature and cooling rate, coupled with the original chemistry of the material, will dictate the physical properties of the rod. The rod is then accumulated into a coil form in the reform tub. Following coil formation, the rods are placed on the hook conveyor. The ends of each coil are trimmed and discarded. A surface inspection is then conducted. The loose coil is then compacted and tied to secure the final package. An identification tag is attached to each rod coil. The coils are then stored or shipped directly to the customer.